Hi everyone, today we'll discuss Bezier curve. What is Bezier curve? It is a mathematical curve used in two-dimensional graphics applications. Right? And if you take this Bezier curve, it has 4 points. Right? This starting and ending point I'll say as anchors. Right, the starting and ending point I'll say as anchors. In between points I'll say as handles. Right, actually if I want to draw a Bezier curve, I need control points. With this control points, right, I'll draw a tangent and I'll approximate my curve. Right, and what is the role of this control point? Control point will give you the direction of my Bezier curve. Right, so in this Bezier curve I could see 4 points, all are control points. Right, and this control points will give the direction of my curve. Out of these 4 control points, 2 points will give you the starting location and ending of my curve. That control points are known as anchors, and the in between control points I can say as handles. Right, coming to the properties of Bezier curve. Right, the degree, how to calculate the degree of my Bezier curve? Right, degree is nothing but control point minus 1. Number of control points minus 1 will give you the degree. Number of control points minus 1. So here if you take, I have 3 control points, degree will be 2. I have 4 control points, degree will be 3. Right, now take this example. This is my starting vertex and ending vertex. In between starting control point and ending control point, in between I have some other control point. So this control point will give you the direction of my curve. Since I have the control point here, I could understand while drawing the curve I should go in the upward direction. Right, suppose take this example. I have 4 control points, degree will be 3. Right, so I am starting from my starting vertex. Right, why I am going up? Because I have control point here. Right, next I have a control point here. Now see the curve, it is coming down and finally reaching my end point. Right, this is how I can draw my Bezier curve. So Bezier curves can be drawn with the help of control points, and the role of control point is it gives the direction of my curve. It will give you the direction of my curve. Similarly, take this starting point of my curve. Right, why I am going like this? Why I am moving in the upper direction? Because I have a control point here. Next, see, I am coming like this because I have a control point here. Next again, right, like this. Right, second property of my Bezier curve is curve passes through the first and the last control point. Next is, as I told, right, I'll be drawing Bezier curve with the help of control points and tangents. Right, draw the tangent, right, and draw the curve, right, so that the curve should just touch my tangent. Right, it should not overlap. Right, it should just touch the tangent and it should reach my ending control point. And next is Bezier curve lies completely in the convex hull of the given control points. Convex hull is nothing but the convex polygon boundary. Convex polygon boundary. It should be within my polygon boundary. Next is I can move my control point. The sixth property is the point that corresponds to U on the Bezier curve is the weighted average of all the control points. Now how to calculate the weight of my control points? Weight of my control point is nothing but the position of my control point. So every point will have its own position, right? That is your weight. Next, multiple control points at a single location will increase the weight. See here, you can see here, I can have a closed Bezier curve. How I can have a closed BCA curve? As you know, BCA curve, it should start from the starting control point and it should end in the ending control point. So if the starting and ending control point are in the same location, I can have a closed BCA curve. Right? Starting and the ending are in the same location. Right? And moreover, the previous property what we have learned, if multiple control points are in the same location, right, weight will be more. Right? See, here I have two control points in the same location, starting control point and ending control point in the same location. Right? So here weight will be more. And the last is, if an affine transformation is applied to a BCA curve, the result can be constructed from the affine images to its control points. Next, we can see the design techniques using BCA curve. Right. So when I want to generate a complicated BCA curve, I can do piece by piece. I can do part by part. That is what we are going to see here. Formed by piecing server BCA curve. Right. So I can draw up to here. This is one piece of my BCA curve. And next I can draw the next piece. Right. I can draw piece by piece. Right. And coming to this C naught continuity, right? So when I draw piece by piece, at last I should join both the curves. There should be a continuity in both the curves, right? For that I have a C naught continuity. C naught continuity is the junction of the two curves, right? The junction of the two curves is smooth, right? When the X, Y, Z of both the curves, right, at this point the value of X, Y, Z, both the curves should agree. Right, at this junction point the value of X and Y should agree. Right. Next we can see what is C1 continuity. C1 continuity means the junction point of both the curves should agree for all the XY values, right? And at the same time, it should agree for the first derivative. First derivative is dx by ds, dy by ds, and dz by ds, right? At the junction. So C1 is, right, at the junction, right? Both the curves should agree for all the xyz value. Both the curves should agree for the xyz value of, and at the same time it should agree for the first derivative at that junction, right? Then only I can have this continuity when I develop a BCA curve piece by piece, right? So here they have generated a relation and they have stated like C1 continuity. The relation states to achieve C1 continuity, right? I have to calculate a ratio. What is that ratio? The length of the last leg of the first curve to length of the first leg of the second curve should be n by m. What is this n and m? Degree, right? N and m are degree, right? So since they are degree, I cannot change this n and m value, right? You know, degree is based upon the number of control points. So I can adjust this um, control points so that this condition will be satisfied. Why I need this conditions to be satisfied? Then only both the curves, since I am developing BCA curve piece by piece, right? After developing piece by piece, both the curves should agree, right? There should be continuity, right, among both the curves. It should be smooth, right? So this is the example they have given, right? For the left curve, the degree is, what is degree? Number of control points minus 1. So here the degree will be 4. 1, 2, 3, 4, 5. Right? So this is the junction for both the curves. So for the next piece, it starts from this point because this is the junction point for both the curves. So 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 1, it is 7. Right? It is 7. 7 by 4 is equal